Thank you very much. It's a great pleasure to be here. I started my career at Macquarie. I was away for 8 years, and I'm really enjoying being back here. So this is a great pleasure. I hope this will be interesting, and I hope maybe even fun. Okay, there are 4 parts to this, so you'll have some sense of how close we are to the end. The first section is called From Vodka to Big History. The second is What is Big History? The third is Bill Gates and the Big History Project. And the fourth is on aliens. And I'll explain what aliens have to do with this talk when we get there. So let me begin by talking about how I ended up teaching big history. I taught Russian history here at Macquarie, and Russian and Soviet history during the Cold War. And during the Cold War, this seemed really significant. I felt it was really important. I was teaching about the dark side, and it seemed very important indeed. And also exciting. Like many students of my generation, I had a sort of adolescent love affair with Russian literature, and I suppose, to be honest, with the idea of the Russian soul. And I began doing research in the tradition of the great French historians of the Annales school, such as Fernand Braudel. And Fernand Braudel made it legitimate to describe the material life of ordinary people. Most Russian historians at that time focused on revolutions, on high politics, on 1917. But a whole cohort of students of my generation began to go in the other direction and to get interested in the peasantry. I had 2 young children. I wanted to know things like, how did you survive as a peasant during a famine? We kept reading about famines. What do you do with the children if there's a famine? So that's the sort of thing that got me interested in food and drink, basic diets of the vast majority of the population. But the alcohol got more and more interesting as I studied this, and I realized that vodka played a huge role in rural life. In a sense, this wasn't a surprise, but what was a surprise is to realize that it wasn't actually alcoholism of the modern form that we're talking about. Vodka was essential for village rituals, weddings, baptisms, burials. It was an item of necessity, and it took me some time to realize this. And that's why it was so powerful for the government, because the government, too, was desperately dependent on vodka revenues. In the 19th century, something like 40% of the revenues that made the Russian Empire a great power came from the trade in vodka. So this was really important stuff. And I eventually wrote a book called Living Water on the role of vodka in Russian life. Now, this was fun, lots of fun, but I had an increasing obsession. This question grew on me, and it's the sort of question I think every teacher's ask. Was Russian history the most important thing for me to be teaching my students? Was that what they needed to learn? And this idea began to grow on me that they needed to learn the whole of history. Now, I wasn't quite sure what I meant by the whole of history, but the idea that we somehow needed to teach the whole thing began to grow on me. Now, this is sort of what I had in mind. Here's a graph of human population growth over 100,000 years. It's a wonderful icon for the arc of human history. So I thought, shouldn't I be teaching the whole story of human history so we can understand what it means to be humans? Now, it seemed ridiculously ambitious at the time, but the question really took hold of me. Should we go from human origins to the Paleolithic era, to the agrarian era, to modernity and beyond, and learn what it means to be a human being? And I thought that's particularly important in today's globalized world. It's a story students needed to know. So here's the arc of human history. Very long, very slow growth in the Paleolithic, faster in the agrarian era. Then look at that spike. That is modernity. And we'll be coming back to that later on. But I then realized there's a problem. Can you teach human history? Because to teach the history of humanity, I realized you need to teach how humans evolved. So I thought, oh my God, I'm going to have to teach a bit of biology. And then to do that, I had to teach how life evolved over 4 billion years. Maybe I need to know a lot of biology. And then to do that, I had to teach how our Earth was formed. Oh my God, I'd have to do some geology now. And this is getting completely crazy. And to do that, I had to talk about how the universe was formed. Now, thank God for the physicists and cosmologists, because they stop at that point. You can't go any further. So here was a starting point. So I thought, okay, that's what it would look like. To teach the history of humanity, it seemed, I had to teach the history of everything. This idea sort of was growing on me. My colleagues thought I was undergoing a midlife crisis. It seemed completely doolally, this idea, frankly. So, big career decision. Should I stay with the Russian peasantry? Lots of fun, safe in career terms, but in 1989, the Modern History Department at Macquarie, we needed a new first-year course. The person who taught it for years suddenly said, that's it, I'm not going to do it anymore. And somehow, I don't know, you know how these things happen automatically, my hand went up in the meeting. And I said, I'll do a course, I'll teach the whole of history. And I thought, oh, what have I done? So this was a huge blunder, I thought. Anyway, so now I'm committed. It's about 1988, actually. So I'm committed to devising a course on the whole of it. I had no idea how to do it. But then with colleagues, and I found wonderful colleagues at Macquarie, and this is very much, I think, to the credit of Macquarie and this institution, from astronomy, from geology, from biology, anthropology, ancient history, and other disciplines, we assembled a course that covered the whole of time since the origins of the universe. And it turned out to be even more fun than writing about vodka. It was fantastic fun. Students loved it. And I'll explain some of the reasons why I think they did. It wasn't necessarily our teaching, it was the content they loved. And after several years, and it did take several years, I think we began to get the hang of this and to figure out how to tell this story. What should I call it? In 1991, I was asked to write an article on this. So I needed a phrase. I couldn't just keep saying, you know, the course that begins with the origins, blah, blah, blah. So I coined this cute phrase, big history. I'm not entirely happy with it, to be honest. There's all sorts of reasons why it's not ideal, but it's stuck. So I think I'm stuck with the phrase big history. And let me confess that I really do believe that big history represents a radical and important new direction in both research and education. I'm passionate about it after more than 20 years. Okay, that's how I got to do this. And now I'd like to to try to give you some sense of what big history is. Some of you may already have a sense, but this is mainly for people to whom this idea is new. Okay, so what is big history? This is my book, Maps of Time, on big history. 2 editions. The second simply has a new preface. It's a history of 13.7 billion years, and it ends by going into the future, by talking about the future. It was my students who pushed me in that direction, by the way. They said, you can't cover 13.7 billion years and stop on a dime. You know, if you cover that much, there's momentum there. You have to talk about the future. And that's turned out to be one of the most interesting things about it. Now, I've been teaching this for 23 years. Through the Big History Project, which I'll talk about later, we're bringing this into schools, and that, I think, is very exciting indeed. I can imagine a whole generation of school children who come to university knowing this story already. And also big history, I'm beginning to see as a framework for deep, profound, rich, interdisciplinary research on themes that cross many disciplines. Here's a comment from a fan of big history on why it's important and what it does. I wish everyone should take this course. Big history literally tells the story of the universe from the very beginning to the complex societies we have today. It shows how everything is connected to everything else. It weaves together insights and evidence from so many disciplines into a single, understandable story. Insights from astronomy, physics, chemistry, biology, anthropology, history, economics, and more. And that's a very simple and clear way of describing what big history tries to do. And the fan was indeed Bill Gates. And I'll come back to his involvement in this project later. Now, what do we teach in a big history course? Just let me give you a list of some topics and dates. Here are some of the main topics of the course I teach. And I am teaching it. I gave a lecture today. I'm teaching this course here. The origins of the universe. So despite being a Russian historian, I lecture on Big Bang cosmology. Don't tell the astronomy department, please. The creation of stars, galaxies, and chemical elements. Some of you will know that most chemical elements, apart from hydrogen and helium, were not created in the Big Bang. They were created in dying stars. The creation of the Earth, the Sun, and the solar system 4.5 billion years ago. The origins and evolution of life on Earth, its evolution over 4 billion years. The origin and evolution of human beings. We could argue about dates. 200,000 is possible, 100,000 is possible, but that's about the right date for Homo sapiens, our own species. Then human history as part of this larger story, and finally the future. And the question that students are dying to ask is, can we learn something from this about how to build a good future? And because this is the point at which my students take over the story, and I can say, we've done our worst with this planet. Over to you. See if you can do better with it. Here are some dates, so you get a sense of the chronology of big history. Now, biologically, we are not designed to handle millions or billions. We're just not designed to do that. So I found that the best way of getting a sense of the chronological shape of this is to divide all the dates by 1 billion. So that's what I'm going to do. So let's imagine that the universe began 13 years ago rather than 13.7, and I'll scale all the dates in the course. Then the Earth would have existed for 4.5 billion years, which is about, I don't know if you want to try and guess these numbers before I put them up. There's no prizes for getting it right or wrong. It's about 5 years on that scale. Now, 5 years we can imagine. Large organisms with many cells would have existed for about 600 million years. That's 7 months, okay? You can remember what you were doing 7 months ago. The asteroid that killed the dinosaurs would have... Now, how many of you know that the dinosaurs were wiped out by an asteroid that landed in what is today the Yucatan Peninsula? I think this is something everyone should... Oh, I'm glad to see quite a lot do. Walter Alvarez, who proved that that was true, is now a good friend of mine and is teaching big history at the University of Berkeley. It's a wonderful story, because if that asteroid had been on a trajectory 5 minutes earlier or 5 minutes later, the dinosaurs would almost certainly still rule, and you and I would not be here. They were wiped out, and that made possible a radiation of mammals who until that time were just sneaky little mouse-like things. So that happened 3 weeks ago. That's when the asteroid landed. Hominins, bipedal apes, would have existed for 3 days. Our own species for 53 minutes. Okay, so I hope you're getting some sense of the chronological frame of this. Agricultural societies appeared about 10,000 years ago. That's 5 minutes ago. Okay. The entire recorded history of civilization. That, by the way, is when most world history kicks in. The entire recorded history of civilization would have lasted 3 minutes. Modern industrial societies would have appeared 6 seconds ago, and humans would have entered space 1 second ago. So I hope that gives you a sense of the sort of shape of big history, chronologically speaking. Now, before I go any further, there's homework for you. This is in case the lecture gets so boring that you can think about this. This is the painting I used as an icon. Do many people recognize it? It's fairly well known. It's my Dutch friends tell me you have to clear your throat twice to say this. So it's Van Gogh. Starry Night over the Rhone, September 1888, Arles, and it's in the Musée d'Orsay in Paris. Now your homework is this. By the end of the talk, I want you to tell me, what does this picture have to do with big history? And I hope you may already be getting some ideas. So that's your homework. I'll come back to this. Now here's the definition of big history. Big history is the attempt to understand in a unified, interdisciplinary way the history of cosmos, Earth, life, and humanity. And that comes from the website of the newly established International Big History Association. If you Google it, it's not the International Buckhorse Association, by the way. It's the International Big History Association, okay? Of which I'm the founding president, and very proud to be that. And we're having our first conference in the States in August this year, which will be very, very exciting. Big history, I think, is exciting to teach because one of the reasons is because it validates big questions. What I mean by this is, well, let me explain. Jacques Monod, the famous French biologist, said the aim of science is to clarify man's relationship to the universe. And I think this is something big history can do. Students love to ask big questions, particularly the really smart, really thoughtful ones. What is our place in the universe? Why are human beings so strange? And we are strange. Does the universe have meaning? So what's their experience when they go to school and they go to university, full of these questions and hoping someone is going to help them answer? The answer is their teachers, and I'm part of the problem as much as anyone else, say, shut up about the meaning of the universe and learn about the difference between acids and bases. We live in a world where education is so specialized, it's very difficult for students to pursue these. So that's a great frustration and disillusionment for many students. Most school and university courses avoid this because most people think, I only have expertise here. Big history courses are transdisciplinary. They encourage students to pursue these big questions and to follow them from discipline to discipline, crossing the borders, blundering across the borders whenever they find borders between disciplines. It's a messy process, but it means they begin to break down some of these intellectual silos. And I think that's why it's very exciting for students. Now, I want to try and give you a feeling for this by talking about some of the things that make big history, in my view, exciting and different. And I want to focus on three. A larger scale, the huge scale of the course itself is shocking and can change how you think about things. Transdisciplinarity and the aim at a universal story, which ends up being like an origin story. So the next part of this talk follows these three themes. And let's begin with scale, the issue of scale. Big history is fractal. I think the idea of a fractal is precise. It's worth studying the past at multiple scales, at very, very large scales, but also at tiny scales, and then integrating what you see at these different scales. So let's take a quick tour of some different scales in time and space. This is just one way of doing it. Let's begin with some familiar types of history and then widen the scale. Let's begin. Each looks at the past at a different scale, raises different questions, and offers different perspectives on the past. So let's begin with national history. Still, as a professional historian, I'm still aware that national history still dominates how we think about the past in all sorts of subtle ways. For example, Australian history is an example. And the underlying question of a national history has got to be something like, what is distinctive about Australian society, about this society? And that implies a comparison with other histories. You compare, how can we compare this with other societies and learn what's distinctive? Now, that already pushes us to widen the lens, to think, what are these other societies? So if we widen the lens, we may ask about regional histories, say, the history of the West. What's distinctive about the West? Or what's distinctive about Asia? And some historians look at the past on these scales. But again, the same sort of question. And they imply a comparison. If you compare regions, ultimately, the comparison has to be with something like the whole of human history. And these are questions explored in world history. And that's a field that is really booming in the States. It's not really taken off in Australia. What's distinctive about human history, I think, is the underlying question of world history. So let's keep widening the lens. Where do you go next? What should we compare human history to in order to understand what's distinctive about human beings? Well, the answer, I think, is with the histories of other large intelligent primates, the Great Apes. And here they are. These are very, very intelligent and smart creatures. I'm sorry, let's go back. I hope you recognize the people at the bottom left. They too are Great Apes, and they're all from the Monty Python crew, of course. So if I'm right, to understand human history, we must compare it with the histories of other species. Do chimps have a history? I'll come back to that. If not, why do humans have a history and chimps don't? Let's widen the lens. Our place in the history of life on Earth. 3 great super kingdoms of life, according to one classification. Archaea and bacteria, these are all single-celled organisms. Eukaryotes, mostly single-celled, but they include many multi-celled organisms. Now, can you find our place in this diagram? This is just a kind of cheap PowerPoint trick to remind you how many species there are. And here's the answer. If you're looking for where we are, that arrow leads you to animals. One little branch on this huge tree. Just a reminder that we're a tiny part of a huge branching phenomenon of life on Earth. And here's a chronology for all of this. The creation of the Earth 4.5 billion years ago, the earliest life on Earth probably 3.8 billion years ago, the first photosynthesizers, oxygen's increasing during this period. Here we get the first eukaryotic organisms, the first sexual reproduction about 1 billion years ago, and here's where we get the first large multi-celled organism, quite late in the story. Vertebrates to land, mammals, and humans. So that's to put us in our chronological place in a story of 4 billion years. Now let's keep widening the lens. Now the point of this is that as each time you widen the lens, you see new things. You lose some things, but you see new things. Now we're going to widen the lens spatially. This iconic picture, the Apollo 8 photograph of the Earth from lunar orbit, I can't tell you how many people I know found this a kind of epiphany when they first saw this, the experience of looking at the Earth from space. And this seems to be true of all cosmonauts and astronauts, everyone who's actually flown in space, and there may be about 200, I think, at the moment, alive on Earth today, has had this same kind of epiphany. Everything began to look different from space. This is just one of many quotes I could have taken from Sultan bin Salman Al Saud, the first Arab astronaut. He flew on the shuttle Discovery in 1985. And this is what he said. The first day or so, we all pointed to our countries, national history, okay? The third or fourth day, we were pointing to our continents, regional history. By the fifth day, we were aware of only one Earth. And over again, you find cosmonauts and astronauts saying the thought that there might be people fighting down there over borders began to seem completely crazy once you saw this place from space. Let's keep going. This is not an artist's impression, it's a photograph taken of Saturn from the Cassini satellite. Now, some of you may have seen this before. There's a lovely little secret embedded in this slide. And there it is. Can you see a little white dot inside that? There's a wonderful Carl Sagan passage you can find on YouTube called The Pale Blue Dot. That is the Earth, that little dot you see on Cassini. And again, I hope again you're getting the sense of as we widen the lens, we see things in new ways, even larger scales. The Milky Way. Now, this is an artist's impression. Okay, this is not a photograph. We're about 2/3 from the center. How big is the Milky Way? Well, our next door neighbor is Proxima Centauri. If you flew there in a jet, a commercial jet, it would take you about 5 million years to get there. That's our next door neighbor. Now, imagine all the stars of the Milky Way spaced out on that sort of scale. How many stars in the Milky Way? 400 billion, that may be on the high side. Some would say 200 billion. How many galaxies in the universe? Perhaps 100 billion. Now, I know all these figures just turn into a sort of blur because our minds are not designed to handle them. So let me give you a feeling for this. What does a billion really mean? Well, count a number each second. 1 and 2 and 3 and 4. How long would it take you to count to 1 million? Well, the answer is about 11.5 days. No sleeping, no food, no time out. 11.5 days of solid counting, okay? To count 1 billion is going to be 1,000 times as long, okay? Which is about 32 years, okay? To get to 400 billion is going to take you longer than the period since the end of the last ice age, just to count at that pace. I don't know if that gives you some sense for the hugeness of what we're talking about. So with up to 400 billion stars per galaxy and at least 100 billion galaxies, there are, according to one astronomer, as many stars in the universe as there are sand grains in all the deserts and beaches of the earth. And by this time, I hope you're getting a little feeling of vertigo, just at the sense of the scale of the universe. And some of my students start saying at this point, my God, we're insignificant, aren't we? Now, I hope I'm going to show you that that is not actually necessarily the conclusion to be drawn from this. But getting the sense of vertigo is important at some point. So what's the focus of big history? Big history focuses on our Earth and its inhabitants and what makes us distinctive in the universe. It's human history in its cosmological context. Okay, that's an attempt to give you a sense of what I mean by scale and how scale can change how you view things. Let me talk very briefly about transdisciplinarity. Big history courses go beyond human history. They're not history courses. They're about the past, but they're as much science as they are history. They offer a coherent narrative linking all of these different disciplines, all of which deal with pasts in various ways. So it's not science or history. They link C.P. Snow's two cultures of sciences and the humanities to create a unified overview of modern knowledge and modern understanding of the past. And they create, what we're doing in effect is laying pathways between the intellectual silos and making it easier to move between them. Now, this idea of silos, I think, is really quite helpful as a way of capturing the nature of modern education and research. Silos are good because you create something manageable, but they also block off the view to so many things. So we're trying to get beyond the silos, okay? Then big history aims at the universality of an origin story. Let me explain what I mean by this. Here's a personal definition of big history, one I like. It's a modern origin story. So think of an indigenous creation story, or the Christian story, or the Muslim story. This is a scientific version of those. It's a unified history of the universe, the earth, and humanity on the basis of modern scientific scholarship. And I include historical and anthropological scholarship when I say that. So most societies, if you think about it, at the heart of their educational system, and by the way, I'm talking as much about Australia 500 years ago as I am about ancient Mesopotamia. At the heart of education were origin stories, and I think this is true of the vast majority, maybe all pre-modern societies we knew of. And these origin stories were very powerful. They gave an overview of knowledge. They helped people map themselves and their societies onto the universe. Here's one way of thinking about them. They are the view from the mountaintop. Learning is like exploring a new country, and educators are leading students through a particular landscape. Modern education describes many landscapes, but it rarely takes you to the mountaintop. That'll sound a slightly romantic way of putting it, but I think it's precise. From the mountaintop, you can see how the landscapes fit together. So big history takes you to the top of the mountain. From there, you see less detail, of course, and for some people that's disillusioning, but you can see how different landscapes fit together. So new things come into your view. And when you return to your familiar landscape, you'll understand each landscape a lot better. I visited Chamonix in 2010, just for a day or two, and I wasn't skiing. I don't ski. So this is Chamonix close up, and here's the view from the mountaintop. I didn't take that. That's from a plane. So that's sort of what I mean. Now, how do you find coherence in such a huge transdisciplinary story? Remarkably, it turned out to be surprisingly easy. And here's just one of several possible unifying themes: increasing complexity. So let me explain very briefly what I mean. The second law of thermodynamics, and if there are any physicists here, please forgive a very crude generalization, but it's basically, it implies that the universe as a whole is sort of running down. It's tending towards simplicity. You don't expect it to get more elaborate, more complex. It's like a ball running downhill. But what we see when we look at the whole story over and over again is something remarkable. Where the conditions are just right, where there are Goldilocks conditions, the downhill energy of entropy seems to be able to drive things uphill and create more complex things. This happens only in pockets in the universe, but it does happen. And this is why the story of 13.7 billion years, is a story of the appearance of increasingly complex and, I would say, interesting things with new emergent properties. And this is where we put humans back at the center of the picture, because modern human global society, frankly, looks like about the most complex and interesting thing that's appeared that we know of in this entire story. So humans start to move back to the center of the story. This is a TED talk I gave about a year ago, 18 minutes, and it's a survey of the story of increasing complexity. And here's just the main story. The universe began simple. There were clouds of hydrogen and helium atoms. There was the cosmic background radiation, sort of photons of energy. There's dark energy and dark matter, which we don't understand. They're presumably because they're very, very boring, they don't do much. There are no galaxies and stars, no heavier chemical elements, no planets, no living organisms, no human societies, of course. Very simple. Then over 13.7 billion years, more complex things appear. So today, most of the universe is extraordinarily simple. But where the conditions are just right, for example, on the surface of rocky planets like ours, more and more complex things have emerged. So that's one through line that takes us all the way from cosmology to geology to biology to human history. And it provides a sort of skeleton for the story. We can talk about thresholds of increasing complexity. And in my course, I talk about 8 main thresholds: the appearance of the universe itself, the creation of stars, the forging of new elements, the formation of the solar system and Earth, the appearance of life on Earth, and the appearance of humans who could learn collectively. I'll explain that in a minute. The appearance of agriculture and the modern era, which increasingly I want to call the era of the Anthropocene. That is to say, the era in which one species, our own, has become the dominant force for change in the biosphere. This is an idea that geologists are taking more and more seriously, and it's the first time that's happened in 4 billion years. No species has ever played this role before. Now, let me look at threshold 6 to give you a feeling for what I mean by thresholds, moments at which something utterly new appears. It's always magical when it happens. Threshold 6 is Homo sapiens. And I hope this illustrates how big history can transform our understanding of human history. No species in 4 billion years has had the power that we wield today in the Anthropocene, this new geological epoch. As the geologists are saying, the Holocene ended about 200 years ago. We've entered a new epoch, the Anthropocene. Now, why do we have such power? What's the source of this power? Chimps don't have it, and yet we share 98% of our genes with them. Why do we have this power? Well, it's modern technology, but where did that come from? These are not the products of isolated minds. Modern technology is the products of millions of human minds cooperating over millennia. So it's the cooperation that's crucial to this. And human language, I think, is the key. So I'm going to take some time to try and explain why this works. Human language links the silos of individual minds, okay, in a way that chimps apparently can't quite do. And it does so efficiently that ideas begin to accumulate from generation to generation. So you get long-term change and you get history. So that's why we have a history and chimps don't. So what makes humans different? Many species can communicate, but human language has crossed a sort of threshold in efficiency that allows information to accumulate in the collective memory. Each generation, in principle, has more information, with the first species in 4 billion years, in which knowledge accumulates at the species level, without clear limits. Yes, there are other brainy species. They exchange information, but the sharing is inefficient, slow, imprecise, and leaky. No pun intended. The result, shared information is lost as easily as it's shared in many species. Here's an example. Shirley Strum is a primatologist. She studied a group of baboons in Africa, in East Africa, and she called them the Pump House Gang because they seemed to have knowledge that other groups of baboons didn't. They were really good at hunting. They were brilliant hunters. So she was fascinated by this. She thought, is this a proof there's culture in baboons? They were virtuoso hunters. They worked in teams, but all the skills vanished when the leader died. So it turned out this information about how to hunt was not held securely in the community. Information could not accumulate in the long term. So there's no real history. That's why there's no department of baboon history at Macquarie University or any other, but there is a department of human history. Now, I want to take you to a simulation here. This is by a friend of mine, Brian Arthur, and it illustrates this idea of a threshold very well indeed. In the center, we have a population of 100 individuals. They're all red except for one who's green. The green one has some information and wants to share it with the others, okay? So what we're looking at is how information moves around in a community. Now, I have controls over to the left here. Each individual lives for 20 ticks. That's 20 moves of the simulation. That's pretty arbitrary, okay? The crucial thing is here. This middle control shows, can you see the arrow? Yes, shows the probability that in any one attempt, an individual will succeed in transmitting information to another individual. Now, I've set it at 9%, okay? Now, over here, you get a graph that will show, click by click, how many people share the information. Now, when I start this, you can watch either the graph or this population map. If lots get it, you'll see more and more green people appear because they're people with the information, okay? So I want to run this simulation several times. So I've got it on slow, so you ought to be able to see things happening. Okay, now, did you see what happened? It'll take you a moment to get used to. Look at the graph over on the right. The person managed to share it with one or two other people, but then it vanished. It fell away, okay? Let's do it again. I'll set it up. Can you see? There's the green person. Okay, now I'm going to run it. Bam. Information vanishes. How many times has that happened to you when you've had a really brilliant idea and you tell someone and they forget it? Okay. Let's do it again. Bam. It's gone. Oh, this is more interesting. Can you see the greens popping up? Now we've gone over 100 and it's crashed. Now, does that look like the Pump House Gang? Information is shared. It can be shared for a time, but it's shared insecurely, and eventually it's going to crash. So let me do just one more simulation with these parameters. Yeah, so same sort of thing. Now, I'll just tell you that I have seen simulations with these parameters in which the whole group did end up getting all the information. And if we went on, we could probably get one. But what I'm going to do now is I'm going to shift the, if I can see this to, I want to shift it to 15%, which turns out to be interesting. 15% probability that an individual in any one attempt will manage to succeed in sharing their information. So oh God, okay. I think that's it. Okay, ready? I've set it up. I can't see the green, oh, there, right up the top right. Crashed. Okay, you see what's going on? Crashed. Now, the point is, we've moved from 9% to 15%. That's not a huge difference in communicative efficiency, but if I'm right, it defines a threshold. Chimps and baboons are just below that threshold. Humans have crossed it. Once you've crossed it, everything changes. And you have a species like us, that has a history. So I hope that helps. In the 18th century, Adam Ferguson, a colleague of Adam Smith's, understood that what makes us different as a species is that we learn collectively. So I call this collective learning. We learn as a species, not just as individuals. And I'm getting behind, so I'm not going to read this whole quote, but it's not that original idea, but it's not as central as it should be. Now, I hope this suggests the power of this perspective. The idea of collective learning suggests that it would pay rich dividends for historians to spend more time, and anthropologists and prehistorians and ancient historians, a lot more time looking at how information is exchanged. Where is it exchanged efficiently? Where is it exchanged slowly? Where is it diverse? Studying, in fact, collective learning. Why is it traveling so fast and at such staggering speed today? The internet is an obvious example of this change. So if I'm right, collective learning or information exchange may be a key to understanding many aspects of human history. Okay, don't forget your homework. Okay, just a reminder. Now, that's the longest section. So the next two sections, I want to talk about Bill Gates and the History Project, and then finally I want to talk about aliens. Okay, so the story of the Big History Project. In 2008, Bill Gates listened to lectures. He retired from Microsoft. He loves listening to lectures. And he listened to some lectures I'd done on big history, and he fell in love with the idea of big history. He said it put everything together. And he contacted me, and I was in San Diego, and so I get this phone call from Bill Gates, and at first I said, yeah, you must be kidding. But it was Bill Gates, and we ended up talking, and he said he loved this stuff, and he felt it ought to be in schools. And so he suggested we work together to create a free online big history course for high school students. And that's what we're doing with the Big History Project. So I'd like to show this. It's from the site of the Big History Project. It's a lovely little sort of cartoon. If I can get this, okay. I'm a historian. I began by studying the drinking habits of 19th century Russian peasants. This was fun, and it was also important, because peasant drinkers paid for the army that made Russia a superpower. But I worried that I was missing the big picture. How much did my students really need to know about Russia? Didn't they also need to know about the history of humanity, or where the earth and stars come from, or how it all began? Historians don't normally ask these questions, but I wasn't completely crazy. People have always asked the big questions, and we call their answers origin stories. 20 years ago, with colleagues from astronomy, geology, biology, and many other disciplines, I began teaching a history course that began with the Big Bang, 13.7 billion years ago. I called it Big History, and I realized it was really a modern origin story. Looking at the really big picture revealed unexpected connections. How everything we're made of came from exploding stars. How a chance asteroid did in the dinosaurs and allowed our mammal ancestors to flourish. How our ability to share and build upon each other's ideas is what sets us apart from all other creatures. The universe as a whole tends towards simplicity. But look around and you'll see the most astonishingly complex things, like our modern human society of almost 7 billion individuals. Big history reveals how such complexity slowly evolved and how rare and fragile it is. A couple of years ago, Bill called me. He loved big history because it linked different areas of knowledge into one unified story. We talked about the fact that education has become too fragmented and disconnected. Students learn facts and skills, but seldom have the chance to connect them all. This turns them off science, math, and even history, because the details alone can't convey the wonder and excitement you get from the big picture. Bill said he wished he had the chance to learn big history when he was young, because it's a framework for learning about anything and everything. Then he asked a question. Would you work with me to get big history taught at high schools around the world? I said yes in a picosecond. That, plus a team of talented people, is how the Big History Project got started. Together, we're creating a free, online and in-class course for high school students. It will tell a story our children need to know as they face the huge challenge of protecting the beautiful and fragile world we have created. So I like that. It captures actually very, in a very light-hearted way, a sense of how this all began. And as you can imagine, for me, this is an astonishingly exciting opportunity. So quickly, our goal is to create a free online syllabus in Big History. All the materials will be online. We're thinking mainly of Year 9 students, but not rigidly. We aim, this is from the website, to make Big History broadly available in classrooms and online, reaching anyone curious about how it all fits together. There's a basic structure of 10 units, each assuming about 10 hours of class time, diverse online resources of many, many kinds. Where are we? We've built a first version of the website. It's very snazzy because we're working with Microsoft people, very good Microsoft designers. Trials began in schools in September in the US. Oh, sorry. Trials began in schools in the US in September, and in February, 2 Australian schools. This is a US-Australian project, began trialing this. We're looking for feedback from them, so they'll tell us what works, what doesn't, so we can improve it. And then, in the middle of next year, we simply release it. We say, no passwords, no charges, it's available to anyone, anywhere in the world, to do what they like with. My personal hope is that, well done, courses like this will bridge the gap between the two cultures. They'll empower students intellectually by giving them a sense of the view from the mountaintop, a sense that they can see over knowledge as a whole. And they will have experienced moving between disciplines. It'll offer the unifying vision of a modern origin story and also the unifying vision of a single global humanity. And that's a sense we're going to need increasingly as we try to collaborate globally on solving big problems. So this is Bill Gates on Big History. I hope you'll think about getting your school involved. He says, if you're a curious student, a parent, or a lifelong learner like me, keep tabs on the Big History project. Learning more about it just might bring you to see the world in a different way. I think he's right. A question I sometimes get asked is, can this exist with other forms of history? And the answer is, of course, yes. It's not going to displace other forms of history. We need history at all possible scales. Like all good science, we need the big picture and, my God, we need the details as well. We need the close-up view and the view from the mountaintop. And that way we understand everything better. We're creating at Macquarie a Big History Institute. The brochure you have gives some of the information. I'm not going to talk long about it, but it'll be a global hub, we hope, for big history. It'll organize research conferences on themes like the Anthropocene, that'll be the theme of our first conference next year, information, energy, rising complexity, a whole series of big transdisciplinary themes like this. Information is another wonderful transdisciplinary theme or intelligence. And collective learning. We'll give in-service courses to teachers and undergraduate and postgraduate courses. We also hope to provide in-service courses more or less for anyone who'd like a sort of crash course in big history. Now, I'm afraid I'm going to skip through these slides. They give a lot more information about this. And I'm going to move on to my last section. We're just about there. What's this got to do with aliens? Well, Big History sees human history in a cosmological context, and it's a great way of helping us think about where our story is going. There's a natural alignment with astrobiology, which is a field that was science fiction 50 years ago, but is now serious science. The study of the likelihood of there being other life forms. And one of the central questions in astrobiology is, are we alone in the universe? Could there be other humanoids out there? And if so, is it possible we might have something to learn from them? Now, this may sound an impossible question, but imagine, here's the brochure from a future university. This is a multi-star system university of the distant future, and it's just about to advertise a new course. This is on the Kepler 22B campus. The new course is called Comparative Humanoid Histories. Now, let me be honest, I've done a long version of this talk on humanoids. I did it for the TEDx Macquarie last year, so this is a very cut-down version of it, very short. My question is, so this course will compare and contrast the histories of different humanoid civilizations in various star systems. So you can imagine essays like compare and contrast the histories of humanoid civilizations in large planetary systems and small planetary systems, or something like that. So my question is, can we imagine what the content of that course will be? And I think we can, and it may have something to tell us. But we begin by defining humanoids very precisely as species capable of what I've called collective learning, therefore capable of accumulating technologies. I don't care what they look like, as long as they're capable of collective learning. So that's what we're looking at, okay? Now, this is the Drake equation. It's a series of questions that you need to ask to get some feeling for whether there are other humanoids out there. And of course, we don't really know, but we know much better than Drake did when he coined this in the 60s. Here's a simplified form. You ask the number of stars, the number of planets that might support life, the number that might support humanoids, the number of humanoids that might be alive now, and so on. Okay. Now, this is my own attempt to do this. I've run through all of these and end up with the argument that in our galaxy, there may have been 40 million moons or planets that hosted humanoid civilizations. Now, I'm not telling you this is right or wrong. I'm telling you this is not an outrageous answer. Lots of people try to do this calculation. Lots and lots, if this is right, okay? Could be very wrong, of course. Now, what are their histories like? Can we compare their histories? Well, I think we can. First, there will be a stage one. I call it childhood. This is a species has crossed that linguistic threshold I talked about. Suddenly they're sharing information. Information's accumulating. The technologies are getting better. They're beginning to realize how powerful they are, right? There's accelerating change, slow build-up of technologies, increasing consumption of resources, populations grow, they spread around their planet, and synergies emerge between them as more and more people are sharing ideas. That's stage one. Stage two, let's call it adolescence. Technological swagger is another phrase for it, okay? This species suddenly gets very powerful indeed. It gets new forms of energy, say fossil fuels, okay, just to randomly pick an example. It develops nuclear weapons. It learns to control the sort of power that's at the heart of the sun. Populations grow rapidly. It develops radio technology, so in principle, other humanoids could notice it now. It's now visible. It's on the radar, okay, of other humanoids, potentially. And at this stage, it's so powerful that it becomes dangerous to itself and to its biosphere. So this is a dangerous stage. It's a dangerous stage two is a dangerous crisis, if I'm right, for all humanoid species. They'll all acquire planet-changing powers, and they'll all be dangerous to themselves and their planet at that stage. So in stage two, it's a real crisis. Now, we entered stage two with what I've called the Anthropocene. This is where we are today, if I've got this comparative history right. Does anyone know this wonderful post-World War II science fiction novel, A Canticle for Leibowitz? Well, it's a very pessimistic novel. It begins in a sort of dark age world, in a monastery after a nuclear war. This is a post-nuclear war. They call the nuclear war the flame deluge. And slowly in the novel you watch science being rediscovered. There's a sort of renaissance. Then eventually they learn to make nuclear weapons once again. And what do they do? They use them again. So here's an image of humanoid species reaching a level which they cannot get beyond. They're so clever, they cannot help destroying themselves. It's a very bleak picture. And it suggests that no humanoid species gets beyond stage two. Therefore, it's no surprise if we haven't encountered them out there, okay? This is really sad. Are humanoid species like kind of galactic fireflies that flicker in and out of existence and then vanish? Or maybe this is too pessimistic. Perhaps at least some of them figure out a way beyond stage 2, and they reach a third stage. So this will be stage 3, maturity and sustainability. How do you get to stage 3 is the big question. It's the main challenge, if I'm right, for all humanoid species. So there's a great essay for the people taking that course, compare different ways of getting to stage 3. Well, like encountering a traffic accident, you have to see the problem. I've got a feeling that my generation saw the problem, but then you have to swerve. We haven't done that yet, and I don't know if that's going to happen, but that's the second thing you need to do. And I believe big history can help with both challenges. It can help us see the dangers, because it puts human history in this large cosmological perspective, and it can help us avoid the dangers, because it helps us see humanity as a global, unified phenomenon, as a species that can perhaps collaborate on global scales in finding solutions. So this is a way of thinking about the future. If I'm right, there may be a reasonably clear shape to humanoid history. Stage 1, stage 2, stage 3. And we're at stage 2 and looking for a way of getting to stage 3, if I've got this right. So this is a challenge all humanoids face. Can we get to stage 3? And if so, only if we get to stage 3 are we likely to meet other species, because then we may survive for another 200,000, 500,000 years. Now, this is the ending. This is one student's response to big history, to just give you a feeling of how powerful it is for many students. And this is not a student of mine. When I was first asked to consider my role in the universe 4 months ago, I did not think I fully realized there was even a living community around me, never mind an Earth full of other humans and an entire universe beyond. But after this long, incredible voyage of exploration, I have a newfound sense of what the universe is. I have learned that we are all part of the global future, and I can make a difference in my life as well as the lives of others. My role is now to change my ways and respect this beautiful planet that granted us life, and to get others to join me. So, what's the painting about? I won't actually force any of you to give me answers. This is my guess. And I don't care what Van Gogh thought the painting was about. For me, it's humans trying to understand their place in the universe. It's a lovely icon for me of that. So, thank you for your attention.